Hi, I'm Paul. We're doing Leetcode, must-know interview questions. Today's challenge is called Interleaving String. It's a medium challenge. Given strings S1, S2, S3. Let's scoot this over so we can see the whole method signature. There it is interleave, and we get 3 strings as input. Find whether S3 is formed by an interleaving of S1 and S2. Okay. I don't think the mathematical explanation of it here is the clearest way to see what it means. It just means, can you make string 3 by taking one character at a time from either string 1 or string 2. So it has an example here where string A is AABCC, string 2 is DBBCA, and here's the output that we want to achieve. And yeah, we can do that. We can grab A, we can grab the DBBC from string 2. We can grab B and C from string 1, A from string 2, C from string 1, and we're done. Now, you can't have anything left over. That's not allowed. Let's see, anything else that we should know? S1 and S2 are somewhere between a length of 0 and 100. So either S1 or S2 could be empty, and S3 could also be empty. All of them consist of lowercase English letters. Could you solve it using only O of string 2 length additional memory space? To be honest, I hadn't really given that any thought. O of S2 length. I don't know. We're not going to do it that way. I mean, I think as a dynamic programming problem, you really need M times N, or I guess maybe I should say string 1 length times string 2 length, either to construct a bottom-up solution or to construct a memoization table for a top-down solution. To me, the top-down solution is a little bit more intuitive, and we're going to go ahead and do it that way. The fact that the strings can be empty is maybe more of a consideration for the bottom-up. But first, let's think about a recursive solution, and then we can convert that into a top-down solution via memoization. So a string, I wonder if it would help to look at this example as we're doing it, but a recursive solution would be to check and see if the first character of S3 matches the first character of S1. And if it does, then we can move ahead one character in both S3 and S1 and recursively check it again. Similarly, if the first character of string 3 matches the first character of string 2, we can move ahead one character in S2 and S3 and recursively check again. Now, if the first character of S3 doesn't match either the first character of S1 or S2, then we're going to return false. So let's try a recursive solution. I'm going to implement a recursive solution, and then we can take a look at it. Okay, let's take a look. So here's the function. The first thing that we want to do is just a basic check that the length of string 1 plus the length of string 2 is equal to the length of string 3. And if it isn't, then we can't solve the problem, so we just return false. If the lengths are equal, then we do a recursive call. I'd like a little more space there. And we call the recursive function with string 1, string 2, string 3, and the initial indexes that we're going to use. 0 for string 1 and string 2, 0 and 0. Start at the beginning of the string. All right, so in here we figure out the index k is going to be the index for string 3, and k is equal to I plus j, initially 0. And what we look for, first of all, is are we done? This would be our base case that I equals string 1 length, j equals string 2 length, and k equals string 3 length. It means that we've traversed all of the strings. And we'll just return true. If that's not the case, we're going to look at the possibilities that we discussed, one of which is that, and we're going to do a sanity check here on the index, I is less than string 1 dot length, so I is in range, and the character from string 3 is equal to the character from string 1. Now initially both of those are going to be 0. If that's true, then we do a recursive call. Everything is the same except we increment the string 1 index by 1. Our other chance is that, again, a sanity check on the string 2 index. Check for a matching character in string 3 with the character in string 2. If that's the case, we do a recursive call and we advance the string 2 pointer, which is j. Now one of those is going to get advanced to 1. Let's say in the example that we used, we matched from string 1, so string 1 would advance to, or I'm sorry, I would advance to 1, and we would call this again string 1, string 2, string 3, 1, 0, add them together, and k is 1. So now we're in the right place on both string 3 and string 1. We've advanced them both by 1, and then we can check the next character in each string. Okay, so that's the recursive solution. It's an exponential runtime, and I'm not sure if it will run within the time allotted. But let's try it. Well, the run will run if the solution is correct. Oh, it's not. Oh, okay, good. Okay, good. Hang on. is interleave rec. I typed it wrong. No, I don't want to copy that. I want to copy this. Okay. All right. Let's try it one more time. All right. Now we'll try and submit it. And as I said, because of the exponential runtime, I'm not sure that it is going to run within the allotted time. All right, we got time limit exceeded on that because some of these tests are using very long strings. All right, but that's okay. This is a good starting point for dynamic programming problems, and then you can modify them to fit a dynamic programming solution. So let me take a look at this. All right, I'm going to go ahead and just type this real time. All right, so we still need to check this basic condition. What we want to do is we want to have a memoization table where if we compute the solution to a problem once, we save it, and then we don't have to compute it again. We can just look it up in the future. So let's see. Okay, so we have to do that. We need a memo table, and that's going to equal new int, let's say m, not m, s1 dot length s2 dot length. Okay. And we want to fill this with -1s. The -1 is just an indicator that we don't have a solution for that table cell yet. So we'll say for int row, for each row in memo, go ahead and fill it with -1. All right. The rest of this stays the same with the exception that we will send in the memo table. Okay. The same thing holds true down here where we have to send in the memo table. I don't like it when that wraps. Okay. K equals I plus J. Check the base case. Have we traversed the entire length of all three strings? If so, return true. All right, if we have already solved this subproblem, and I'll talk about what I mean by subproblem in a minute. Not equal. It's not equal to -1. If it is equal to -1, it means we haven't computed it yet, and we're going to have to go ahead and compute it. If we have computed it, then we can return memo memo I j equals 1. We're using 1 and 0 as true and false because this function returns a Boolean. All right. So by subproblem, I mean, so for I and j, memo ij is true or 1 if a prefix of string 3 with a length of I plus j is an interleaving of a length I prefix of S1 and a length j prefix of string 2. I hope that's clear, but let's look at the example here. So the way that this is put together. First we have A from string 1. So what that means is that memo 1, 0 is memo 1, 0 is true. Memo 2, 0 is true. Now we're pulling one from string 2, so memo 2, 1 is true. Memo 2, 2 is true. Memo 2, 3 is true. Okay, so that's what the memo is for. So the memo table. So we don't have to recompute subproblems. It may not be obvious at first why we would have to recompute subproblems, but so consider this possibility. We have S1 is x, 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 S2 is x, 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 S3 is x, 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 x. That's going to fail, but it's only going to fail after we try, every possible combination of substrings from S1 and S2, and it's going to mean that we're going to recompute a number of subproblems, and we don't want to do that. So that's the point of memoizing them. We compute subproblems one time, and then we are done. All right, so continuing from here, we still have Boolean B1. Initially, we're going to set it to false. And we're going to say, actually, let me move it up here. What we want to say is, if I is less than string 1 length, again, that's just a sanity check, and the characters are equal, then we will, okay, now where does that match with? I think I need one more on the if. No, see, now I've got too many here. If I1 equals S1 dot length, and I don't need this, S3 char at, and that's char at, now which one do I need? This one, okay. In that case, B1 equals this I plus 1 j, and we also have to send in memo. Okay, we're going to do the same thing with B2. Initially, it will be false. If j is less than S2 dot length, and I don't need that, S3 char at S2 char at j, I don't need that. B2 equals, okay, and send in memo. Okay. So we are going to have a, oh yeah, what we need to check now is memo ij. We got to set that to something. And we're going to set it if A or A, B1 or B2, then memo ij is true. If neither B1 or B2 is true, we're going to set it to 0. And we are going to return, yeah, B1 or B2. That's right. Okay, let me look at that for just a second. Okay, that should work. For any given I or j that we pass in here, we have two chances of being successful. One is that the next character of string 3 matches the next character of string 1, or next character of string 3 matches the next character of string 2. If either one of those is true, then we can set memo ij to true and return true. Otherwise, we set memo ij to false and return false. And this should run faster than the compile error. Oh, I saw that. I was looking right at it and I forgot to put it in there. But in any case, it should array, not array, arrays. Whoa, whoa. Okay, fixing the mistakes too fast. Here, try it again. Uh-oh. Index out of bounds. Okay, let's go here. +1. Okay, so what can the indexes, what values can the indexes take on? Well, if the length is, let's say, n, then the index can take on values from 0 to n. So therefore, the array has to be 1, the dimension of the array has to be 1 greater than the length of the string. All right, let's try it one more time. Okay, now comes the real moment of truth, which is to try and submit it and see if it runs in an appropriate period of time. It appears that it did. 1 millisecond. Well, that's a lot better than whatever we got last time, which went completely off the charts. Okay, so that is top-down dynamic programming for this problem. You can also do it bottom-up if you want to do an exercise in bottom-up dynamic programming. It can also be done bottom-up. And that's it. Feel free to like, subscribe, comment, and see you next time.